Hey, what's up, guys? In this video, I'm going to talk about counting islands. It's a LeetCode medium problem. I have the code finished up over here, and the structure of this video is I'm going to explain the problem, a visualization of counting islands, and how to think about this problem, and then finish it off with the explanation of the solution as well as the code. So, counting islands is a really popular interview problem. It is given a 2D array of ones and zeros. Count the number of islands. An island is surrounded by water and is formed by connecting adjacent islands horizontally and vertically. You may assume that all four edges of the grid are surrounded by water. So 1, 1, 1, 1, 0, 1, 1, 0, 1, 0, and so on and so forth. This will return 1 because there are 1 islands that are all connected. In this example, it would return 3 because there's 3 disjoint islands. So to visualize this, let's open up a text editor. And in order to fully conceptualize this problem, we can draw the red boxes over the current islands. So probably first in the different or 0. If it's 1, that means we discovered land. If it's 0, that means we have water. So to do this, we would have a queue that would contain the islands, and we would also have a queue that is water. So we can search the surrounding area until we find water. And when we found water, that means that we discovered the extent of the boundaries of this island. And now we can go ahead and clip off this island and mark these as gray, as in these have already been visited. So now our algorithm has said that we visited these nodes. Now, if we see these nodes again, we don't have to visit them. And we can increase an island counter by 1. So now we have 2 more open nodes that we can go ahead and explore, and we can go ahead and start looking at them. So let's say, for example, we discover that this isn't water. We go backwards because we're going left to right, up and down. We see that this has already been visited. We can go ahead and skip it. We go here. We see that it's not water, so we add 2 more nodes on top to visit the right and the bottom. We can also add the back, but that's already visited. We go down. We see that it's also not water. Go ahead and down. Now that we're done with this node, we can move this queue up. And now we go back to here, we go down, we see that this is a 1. So we add it to the island queue. And now that we have the island, we found the we found the island, so now we have to do a BFS to find the boundaries. We go left, we see it's water. We go right, we go left, right. We see it's water. We go down, see it's water. Go up, see that it's water. So now we found the extent of our boundaries. We can increase this by 1, so now it's 2. It's our island counter. And we have a couple more nodes on our water queue, which we can start exploring. So you see here, by the time this algorithm is done, it would have discovered all the islands, and our island counter would be 3. So how do we implement this in code? You can go ahead here and start commenting this out. So first of all, let's go ahead and implement the initialization logic. We need a visited set and we need a queue. So I'm using the queue library in Python. So we go ahead and add the first node 0, 0, and we set the islands to 0. This initializes our logic, and we start out with an empty grid. So while the queue size is greater than 0, that means that we have additional nodes to explore. We get the coordinate of the current node that we're trying to explore, and if the value isn't visited, then we can go ahead and skip it. This is a logic to not visit repeated nodes. So without this logic, our loop will never end. Now we do a simple boundary check. If it's greater than the length of the grid, or if it's less than 0, then this will break. And then we add the current coordinate onto the visited list. Just some bookkeeping stuff. And now this is where the logic starts getting, this is where the algorithm logic starts coming in. So we take the island and take the value of grid. We check if the island is 1. This means that this checks if we hit land or not. And if we did hit land, then we go into a sub loop, which is create a new queue. This explores the breadth of the island, the boundaries. We add the surrounding areas, and we follow a similar pattern of logic. And while the island queue is greater than 0, then we get the current coordinate. We find the inner x and the inner y. This will take the inner parts of the island, and we follow a very similar piece of logic. If it's already visited, that means that we visited this. If it is out of the boundaries of the grid, then this point is invalid. If it's 0, that means we hit water again, and we can put that on the queue above this. This is more water to explore. And then we add the value to the visited to make sure we don't hit it again. And this is really important because this visited list will tell our main queue, the water exploring queue, that this land has already been visited. So this is the part that makes all of this work, because when we explore the breadth of the island, then all the points in the island are added to the visited queue. So now when we fully explore the breadth, that means that if we hit the same island again, it won't be registered. Now we add the surrounding area onto the island queue, and and once this queue is done, then we increment the islands by 1. So we want to basically hit land, explore the surrounding area completely, and then count the island. This is to make sure that we add all the nodes explored onto the visited stack the visit set before we count this island to make sure that we don't count it twice or 3 times or whatever. And then we just add the surrounding areas on the current coordinate that we're visiting, that we discovered the island, and now we're done with the while. This is a search problem. It's a BFS inside another BFS inside. This could be a DFS too. I chose BFS because the logic is mostly the same, so it's mostly copy and paste. And after that, we just return the islands. So runtime for this, since we're going to be exploring every node twice, is going to be n log. It's going to be O of nm, and this should work 100%. So there you go. This is counting islands, very popular interview problem. Good luck.